Bottom line, I simply want to make ever better car, no matter what kind of the powertrain they have.
Tesla's early mover advantage won't keep it at the top forever. Well, Toyota will see to it. Their answer to Musk's hegemony? Solid-state batteries. After years of focusing on hybrids and lagging behind in all-electric adoption, Toyota has unveiled a solid-state battery prototype that promises over 1,000 kilometers of range and ultra-fast charging in under 15 minutes. With over $13 billion invested in battery innovation and a rollout strategy that begins with Lexus and expands to mass-market models by 2028. Toyota isn't just catching up. Its new battery may just as well crush Tesla's lead. Let's see how things are playing out. Toyota's late entry and rapid acceleration in EVs. Toyota is changing. It's changing fast. For much of the 2010s, Toyota held firm in its belief that hybrid technology was the most practical path to carbon neutrality. This conviction was embodied in its flagship hybrid, the Toyota Prius, which debuted in 1997 and became one of the best-selling hybrid vehicles in the world. By 2022, Toyota had sold over 20 million hybrid vehicles globally. However, the tide has now turned. There is not going to be enough room for the middle ground in the future. It's either or, and Toyota realizes it. That being said, Toyota's pivot toward full electrification is beginning to take tangible shape. In 2023, Toyota sold approximately 150,000 EVs worldwide. This was a major leap. You see, just a year earlier, the Japanese automaker could only manage to sell a little over 24,000 EVs, mostly through its bZ4X crossover SUV and a few other regional offerings. The nearly five-fold increase in 2023 EV sales reflects both a sharp change in Toyota's production strategy and a growing global demand for fully electric options. The increase also reflects Toyota's recognition that hybrid dominance alone will not secure its place in the future automotive market. The market is changing. So is Toyota. Part of this new approach is Toyota's decision to use Lexus, the company's luxury division, as the vanguard for its most advanced electric technologies. Lexus, which sold over 824,000 vehicles globally in 2023, is not only a symbol of high-end automotive engineering, but also a strategic testing ground for Toyota's most premium innovations. The Lexus RZ 450e, launched in 2022, marked the brand's first dedicated battery electric vehicle. Designed on the eTNGA platform shared with the bZ4X, the RZ 450e reflects Toyota's attempt to marry luxury performance with electric efficiency. Moreover, Lexus has announced plans to go fully electric by 2035, with some markets like Europe and North America transitioning even earlier. This staggered rollout allows Toyota to fine-tune its battery technologies, powertrain software, and production logistics before scaling up to mass-market Toyota-branded EVs. The company's renewed vision is encapsulated in its Beyond Zero initiative, a wide-reaching electrification campaign announced in 2021. As part of this initiative, Toyota has committed to achieving annual sales of 1.5 million electric vehicles by 2026. This target is ambitious, considering that, as recently as 2020, Toyota's EV output was negligible in global terms. To support this transition, the automaker has pledged roughly $13.5 billion in battery development and electrification by 2030. This investment covers not only new vehicle platforms, but also battery research and development, solid-state battery trials, software integration, and the construction of dedicated EV production lines. By 2030, Toyota aims to offer 30 new electric models across both the Toyota and Lexus brands and reach annual sales of 3.5 million EVs globally. Toyota's global production network is also being restructured to support its electric ambitions. In the United States, Toyota announced a $1.3 billion investment in its Kentucky plant in 2024 to prepare for EV production, with the first US-assembled BEV expected to roll off the line in 2025. Simultaneously, a battery manufacturing plant is being constructed in Liberty, North Carolina, scheduled to begin operations in 2025 and expected to produce enough batteries for 1.2 million vehicles annually. In Japan, Toyota's Motomachi plant, one of its most historic production sites, is being revamped to serve as a key EV assembly hub. The company is also exploring production capacity increases in Europe, particularly in the UK and Turkey, where existing facilities can be upgraded for EV output. Just a couple of years back, Toyota executives were publicly voicing skepticism about fully electric vehicles, citing concerns about charging infrastructure, battery sourcing, and consumer readiness. Former Toyota president Akio Toyoda famously warned that a rapid transition to EVs could strain global electricity grids and hurt the environment if power generation remained carbon-intensive. While such concerns were not unfounded, they led to a perception that Toyota was lagging behind companies like Tesla and Hyundai in embracing the electric future. Now, however, Toyota has recalibrated its stance. The automaker is placing a strong emphasis on battery innovation, including plans to commercialize solid-state batteries by 2027. These batteries promise faster charging times, longer range, and greater safety than conventional lithium-ion counterparts. If Toyota succeeds in scaling this technology, it could leapfrog many competitors in terms of performance and durability. In 2023, Toyota engineers reported achieving a prototype solid-state cell capable of a 1,000-kilometer range on a single charge, with a 10-minute recharge time. Despite its late start, Toyota's electrification strategy benefits from its experience in lean manufacturing and global logistics. The company's mastery of supply chain management, quality control, and cost optimization will become critical advantages as the EV sector matures and margins tighten. Moreover, Toyota's global dealership and service infrastructure, particularly in markets like North America, Southeast Asia, and the Middle East, gives it a logistical edge in EV rollout and maintenance support. Critically, Toyota's approach also shows signs of regional adaptation. In China, the world's largest EV market, Toyota is collaborating with BYD, China's top EV manufacturer, to develop electric sedans tailored to local tastes. Their joint product, the Toyota BZ3, was released in China in late 2022 and leverages BYD's Blade battery technology for enhanced safety and energy density. In Europe, where stringent emissions regulations have rapidly pushed EV adoption, Toyota is gradually increasing its electric offerings to comply with tightening fleet average carbon dioxide standards. By 2025, it plans for at least 10% of all European sales to be battery electric vehicles, with the remainder being hybrids and plug-in hybrids. While not as aggressive as European rivals like Volkswagen or Renault, this transition marks a clear pivot from its previously hybrid-exclusive approach in the region. The era of Toyota sitting on the sidelines of full electrification is over. The coming years will test whether the world's largest automaker can reinvent itself fast enough to lead in the very arena it once hesitated to enter. Toyota's infrastructure and strategy. A major pillar of Toyota's electrification strategy is the development of a fully dedicated EV platform designed for long-term scalability and global adaptability. Unlike early EV attempts by various automakers that repurposed internal combustion engine architectures or modified hybrid platforms, Toyota's new architecture is purpose-built to optimize battery placement, aerodynamics, vehicle dynamics, and weight distribution. The new platform is part of Toyota's larger Toyota New Global Architecture, or TNGA initiative, which has already streamlined production across internal combustion engine and hybrid models. However, the battery-focused expansion, often referred to internally as ETNGA, will push modularity further, enabling a broad spectrum of vehicle types to be produced using shared components. This includes everything from compact city cars to three-row SUVs and light commercial vehicles. Toyota has also said that many of these vehicles will be produced on shared lines with high levels of automation, using adaptable tooling that can shift between models with minimal reconfiguration. This approach is being piloted in new and existing factories in Japan, the United States, and Europe, where Toyota is investing billions to retool assembly lines, implement AI-driven quality control, and introduce robotics that can operate in tighter spaces with increased precision. A central target in Toyota's manufacturing overhaul is the reduction of vehicle complexity. The company has stated its goal to cut the number of individual components in EV assembly by up to 30%, a move that will not only drive down costs, but also speed up production. For example, the company is working on integrating more functions into fewer control units, streamlining wiring harnesses, and adopting new manufacturing techniques such as gigacasting, where large aluminum components are produced as single pieces to replace dozens of smaller ones. These innovations are expected to significantly reduce labor intensity and improve structural rigidity, both critical for EV performance and safety. Toyota is also investing in digital twins and predictive maintenance systems to monitor equipment wear and process variation in real time. These technologies, already being deployed in some of its more advanced plants, will allow Toyota to maintain consistency across multiple continents while scaling production aggressively after 2026. Through its global network of R&D centers, including those in Aichi Prefecture in Japan, Zaventem in Belgium, and Ann Arbor in Michigan, Toyota is coordinating the rollout of its next-gen EVs with a long view. It is aiming not just to participate in the EV market, but to redefine it with vehicles that are cheaper, more durable, and more widely accessible over the long haul. So, how does Toyota plan to outdo Tesla? A better battery? Let's see how that will work out. Tesla's 4680 battery versus Toyota's solid-state prototype. As global competition intensifies in the EV sector, the race to dominate next-generation battery technology has emerged as a defining front. Two industry giants, Tesla and Toyota, are pursuing fundamentally different approaches to solve the challenge of battery performance, safety, and scalability. Tesla's 4680 cylindrical lithium-ion battery is already deployed in production vehicles, while Toyota's prototype solid-state battery promises dramatic improvements in energy density and charging speed. Let's compare the two. Tesla's 4680 battery cell, first unveiled at the company's Battery Day event in September 2020, is a cylindrical, tabless lithium-ion cell that marks a significant departure from the earlier 2170 and 18650 cells used in Tesla's earlier vehicle generations. The 4680 cell increases energy storage per unit volume while reducing internal resistance through a tabless design, which enhances thermal performance and allows for faster charge and discharge cycles. By removing the traditional current collector tab, Tesla reduced the internal path electrons must travel, thereby minimizing heat generation and enabling more efficient energy flow. The 4680 battery is actively used in the Texas-built Tesla Model Y and select variants of the Cybertruck produced at the Giga, Texas facility in Austin. Tesla claims the 4680 battery delivers between 600 and 700 kilometers of range per full charge, depending on the vehicle's configuration, aerodynamics, and battery pack size. This represents a notable improvement over earlier battery designs. Additionally, the 4680 cell supports fast charging capabilities that enable a 10 to 80% charge in approximately 25 to 30 minutes when connected to Tesla's proprietary supercharger V3 stations. However, the 4680 is still a lithium-ion battery and therefore retains key limitations inherent to the chemistry. The electrolyte is a flammable organic liquid. which poses a fire risk under conditions of overheating or internal short circuits. While Tesla employs extensive battery management systems and thermal controls, incidents of battery fires, though rare, have been reported. Furthermore, like all lithium-ion batteries, the 4680 undergoes gradual capacity degradation over repeated charge cycles, especially under high temperature or high current conditions. Industry estimates suggest that lithium-ion batteries lose around 10 to 15% of their initial capacity after 1,000 full cycles, though Tesla's active thermal regulation helps mitigate this degradation. In contrast, Toyota's solid-state battery replaces the liquid electrolyte with a solid material that can conduct ions while offering greater thermal and structural stability. This architecture is inherently safer, as solid electrolytes are non-flammable and eliminate the risk of thermal runaway, where a battery catches fire due to internal overheating. Toyota's prototype, first publicly disclosed in 2020 and further detailed at a technical briefing in July 2023, is designed to deliver over 1,000 kilometers of driving range on a single charge. Moreover, it aims to support ultra-fast charging, with a 10-minute full charge being the target. This would radically outperform any existing lithium-ion EV on the market. Beyond performance, the solid-state battery offers several additional advantages. Due to the stability of solid electrolytes, these batteries can operate efficiently at wider temperature ranges, particularly in sub-zero climates where conventional batteries suffer from reduced conductivity and performance loss. Solid-state batteries are also expected to last longer, with early lab tests showing minimal degradation after over 2,000 full cycles. This would allow EVs to exceed 800,000 kilometers of driving without substantial loss of battery capacity. However, Toyota's solid-state battery remains in the prototype stage and is not yet commercially available. Mass production is targeted for 2027. If successfully commercialized, solid-state batteries could reduce or even eliminate the need for vast, expensive fast-charging networks. With ranges exceeding 1,000 kilometers and 10-minute charging, drivers would be able to travel as freely as with gasoline-powered vehicles without EV infrastructure bottlenecks. This could be particularly impactful in developing regions where charging networks are sparse. The enhanced safety of solid-state batteries could also reshape the insurance and regulatory landscape, as battery fires and thermal incidents are among the most concerning risks associated with EVs. A safer chemistry could lead to lower insurance premiums, simplified safety regulations, and increased consumer trust. Regulatory bodies in the EU, US, and Japan are already studying the implications of solid-state deployments, including how such batteries may alter crash standards, thermal resistance protocols, and recycling procedures. Tesla's 4680 battery pack can serve as a load-bearing element in the chassis. This innovation reduces vehicle weight, increases rigidity, and lowers production costs. Solid-state batteries, being lighter and denser, could allow for even greater design flexibility. If Toyota's solid-state battery meets its performance goals and can be produced affordably, it could render today's lithium-ion EVs, including those powered by Tesla's 4680, outdated in key metrics such as range, longevity, and safety. It could also threaten the dominance of current battery suppliers like CATL, LG Energy Solution, and Panasonic if they fail to adapt. So, what's Toyota's plan? Toyota's global rollout plan. Toyota Motor Corporation, the world's largest automaker by sales volume, is taking a measured yet ambitious approach to electrification through a multi-phase global rollout of EVs. Lexus, Toyota's luxury division, established in 1989, is serving as the proving ground for solid-state battery technology. The company has confirmed that, for now, a production model equipped with a prototype solid-state battery would be released in limited numbers. Lexus customers, accustomed to premium innovation, are more likely to tolerate early-stage limitations, allowing Toyota to monitor battery performance under diverse conditions across critical markets like North America, Japan, and Europe. This strategy helps insulate the mass-market Toyota brand from the risk of deploying a still-developing technology too broadly, too soon. Toyota's ultimate goal is to bring solid-state batteries into the mainstream after key technical and economic barriers are overcome. This gradual rollout mirrors the successful deployment of hybrid technology in the 1990s. The Toyota Prius, which launched in Japan in 1997 and globally by 2000, was initially niche before it became a mass-market success through scale-driven cost reductions and manufacturing efficiency. Similarly, Toyota now aims to begin mass production of solid-state batteries between 2027 and 2028, expanding their use to models like the BZ series, including the BZ4X SUV, as costs decline and supply chains stabilize. Supporting this global EV transformation is a robust international research and development R&D infrastructure. In Japan, Toyota's headquarters in Toyota City remains the epicenter of innovation, supported by its Battery Development Center and a joint venture with Panasonic known as Prime Planet Energy and Solutions. In Europe, R&D hubs in Zaventem, Belgium, and at Toyota Motor Europe are tailoring platforms and technologies to regional standards. Meanwhile, in the United States, the Toyota Research Institute, or TRI, and the Ann Arbor R&D campus in Michigan are integrating advancements in software, vehicle architecture, and safety systems to complement battery development. This multinational collaboration ensures that Toyota's EV technologies can adapt to a variety of market needs while maintaining consistent performance and reliability. To fund this transformation, Toyota has committed over $13.5 billion through 2030 to battery R&D, supply chain improvements, and factory upgrades. A notable example is Toyota Battery Manufacturing North Carolina, a $3.8 billion facility slated to begin production in 2025. In Japan, the company is converting its Teiho plant in Aichi Prefecture for solid-state battery production. These facilities will be instrumental in producing new solid electrolytes and battery materials, such as lithium, nickel, and sulfide compounds, critical for solid-state battery performance. Another cornerstone of Toyota's electrification plan is its electric vehicle platform architecture, known as ETNGA, Toyota New Global Architecture for EVs. Already used in the BZ4X and its twin, the Subaru Solterra, this platform is engineered to evolve with new battery formats, particularly solid-state packs. Toyota's solid-state batteries are projected to offer ranges between 1,000 and 1,200 kilometers per charge and ultra-fast charging in under 15 minutes. These improvements directly address common consumer concerns about range anxiety and long charging times, particularly in regions where public charging infrastructure remains underdeveloped. If successful, Toyota's technology could ease the path to mass adoption of EVs and drastically alter customer expectations around performance and convenience. This transition also represents a shift in focus for the broader EV industry. In recent years, the spotlight has often been on software innovations, from self-driving algorithms to over-the-air updates, a trend led by Tesla. Toyota's approach reflects a potential rebalancing of priorities, where the emphasis returns to materials science, energy storage, and hardware reliability. This pivot could redefine how success in the EV sector is measured, particularly as regulatory pressures in regions like the European Union, California, and China tighten emissions and efficiency standards. Toyota's strategy could also accelerate broader changes across the automotive industry, while companies like Volkswagen, partnered with QuantumScape, Ford, working with Solid Power, and Hyundai have signaled interest in solid-state batteries. None have laid out production timelines as concrete as Toyota's. If Toyota achieves mass production first, it could force rivals to adapt or risk falling behind. Additionally, the transition to solid-state technologies may reshape global supply chains, reducing reliance on cobalt and increasing demand for other materials like sulfur or lithium in different chemical configurations. Despite its growing focus on EVs, Toyota continues to hedge its bets. The company remains committed to a diversified approach that includes hybrids, plug-in hybrids, hydrogen fuel cell vehicles like the Mirai, and combustion engines running on synthetic fuels. Still, solid-state batteries are increasingly positioned as the company's cornerstone for long-term carbon neutrality. President Koji Sato reaffirmed in 2023 that while Toyota remains open to multiple technologies, the solid-state battery is central to its future strategy. If it delivers on the promises of longer range, faster charging, and safer battery systems at a competitive cost, Toyota will surpass the current EV giants, setting the pace for the next era of automobile innovation. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.